Hello, it's me again with my favorite lightweight pencil. Today, yes, you can see the date. We got some quick challenge doing my class teaching today, and I think would be nice if we gone through the question again here because it is quite a question there. So let's do that to just in case some of my student and the public, we all interested in it. So here we go. We have simplifying. Before we start, when we work on algebra, quadratic, you might also need to remember some of the identities we have. For example, a plus b all square equals to a square plus 2ab plus b square. We should have known that already, but then just in case, I will write that here to remind myself a bit. And then we have a plus b, a minus b, the difference of 2 square. So this is something that we might need to know when we use them. All right, so, and then what we can do is like we simplify that one. Also, we have our identity square theta plus sine square theta equals to 1, and our tan theta equals to sine over cos. All right, with that, everything ready should be in my brain. So let's get started. So, what is it here? I got the sine and the cosine. I cannot take that. So what I can do is that I will try to change one of them into sine. So cos, that will become 1 minus sine square x. And then the rest of them, I didn't move that, so I just copy it. Then moving on, I expand that. We have 4 minus 2 minus, minus become plus, 2 sine square x, and then minus 4 sine square x. Right. So from now, I have the make over, like simple out, negative 4 minus 2, 2, and then I have 2 minus 2 sine square x. Hey, there's something similar there, so I take a 2 out. So both of them, I have 1 in the first one, and then the other one is like just have sine square x. Then going back to 1 sine square, I can put it into cos square x. And this is the answer there. Pretty easy, isn't it? If you kind of feel that which one to use from there. Okay, so I think I should do some music. While we're moving on to the next one, I was wondering, like, you just listen to me to it, or you can see what I'm typing. And we can just read through that. Anyway, for this, we got sine and we got square there. If you're very confident, here's another trick. You can leave that as sine and cos, but then if you're not quite there, I will put sine beta equals to A and cos beta equals to B. With that, I will have something like this. Hey, that makes us so much more comfortable because this is the identity here. So one of the trick is do not allow yourself to be squared by the sine and cos because they meant to look weird to frighten you. Just like how the little animal, you have to like enjoy, like enlarge themselves to scare the friend. All right, once we got that, we put our sine square in again. Now with that plus and sine there, we have 1 minus 2 sine beta cos beta. Actually, it's just that easy. We have to just make sure we feel the vibe with it. Again, this one, we have cos, and this is square. In my mind, then I will think of it as quadratic, especially the command term is factorization. So to do that, we will, again, make ourselves feel better. So let cos x equals to 1. I use substitution with it to a. You cannot be 1. So a squared plus a minus 6. Then you can get to the cross product. A times a equals to a squared. 2 times 3 equals to 6, and it's a negative. So one of them have to be negatives. Then we think of the middle one. It's a positive one, so which means that the positive one have to be the larger number. So we double check that. All right, which is a match. So all you need to do is make it official. So we have 2 minus a minus 2 and a plus 3. Now we put it back to the cosine because they ask you to factorize the cos. And this is done with a piece of cake. All right, next question. Here we go. Next question we're talking about is like, I need to zoom in a bit. Okay, you got it. It just takes some time to zoom. All right, to zoom that in, we kind out those. So first of all, we simplify. I can see a common factor in the numerator there. So 1 minus sine square y over 2 cos y. I didn't do anything with the denominator, so I will have to copy it. And then, because 1 minus sine square becomes cos, so I have 4 cos square y over 2 cos y. Now all you need to do is cancel them out. 2 times 2 is 4. 1 cos there, so altogether, just so easy. So this will be 2 cos y. And if you have done up to 1 to 4, I'm very happy with those. So here is the bonus question. It's a bit annoying, so don't fall for it. It's okay, we can get things done. So here is that. We have to show that. Show the command term means that you have to make sure this looks like this at the end. This is the command term show. It's not calculating it. You will throw things on the other side. We don't solve for x. Don't do that. So we need to just make this looks like change the look of it, become time. So which means that I'll work on the left-hand side. Cos x over 1 minus sine x minus cos x over 1 plus sine x. They are, to me, they are fraction with different denominator. So we have to play around with it. So we have cos x times 1 plus sine x over 1 minus sine x times 1 plus sine x. So both of them multiply by 1 plus sine x to make sure the value doesn't change. Same with the second term. This time we have to multiply the 1 minus sine x over 1 minus sine times 1 plus cos. When we up to this point, when we start thinking again, this is a minus b, a plus b. Wait, it is difference of 2 squared. So now our denominator can be combined, become 1 minus sine square. Now the annoying bit is the numerator. We just have to expand that. Be careful, it's the minus there. So where we have the cos x plus sine x cos x minus cos x plus sine x cos x. Now again, this plus and minus will be gone. This can become a cosine. So now I have the rest of the like term there. So I will have 2 sine x cos x, because I got 2 chunks there, over cos square x. Then what we need to do is cancel one of the cos. I find things getting there. So sine over cos here, sine over cos equals to 10 equals to 2 tan x. And you do not have to write anything more, because all you need to do is telling us that, oh, this is tangent and what we want there. Yeah, this is a little quick challenge from my class, and I hope you'll be interested with it, and we can have more trig expression in the future. Thank you.